How to create a custom door panel using EpoxAmite high-temp laminating epoxy. Today I'm going to show you how I use the EpoxAmite HT and carbon fibers to create a brand new door panel for this vehicle that I'm currently restoring. The door panels were old and falling apart, and I wanted to make something new and nice looking, that's strong, that's going to tie in the interior of the vehicle together. Now, for this project, I had to rescue one of the original door panel cards. This is the insert that was inside the door panel. We're going to use this as a template. This is going to be our guide as far as size, shape, and where the drill holes need to go in order to make this fit the original door. And if you notice, I do have a piece of melamine board down. That's my working surface we're going to be using to create the door panels. It has a nice matte finish to it that I like, and I wanted that finish as the face of the door cards that we're making. So that's why I chose to make the actual panel on top of this working surface. Also, it's cheap and readily available. Now, after I did my outline for the shape and size of our door panel, I'm going to put some markings down. We're going to put an insert into the panel itself. This paper right here is a special paper. It's called transparency film. The reason why I'm using this transparency film on our project for the inlay is because we already did a project where we had to inlay paper into epoxy, and we found out that this transparency film works the best. It will not bleed out the colors, it will not disform, and will definitely look good on our finished projects. But this particular film is called Display Trans 2 Backlight Media, and it's made by Epson, in case you wanted to hunt down this specific product that we used. The printed pattern on the transparency paper is not just random. This is the fifth generation of the Volkswagen GTI plaid seats. And we wanted to tie in the rest of the interior, the door panels, with the seats. So that's why we chose to print this specific pattern on our inserts. That's going to be then laminated into our door panel. Simply trace out the shape that you want, and then we're going to cut it using a straight edge here. This is to make sure that our cuts are nice and straight, because this is going to be visible. We don't want to have any kind of wavy pattern that you get with cutting these by hand. So once we have these cut out, we can then proceed to get them ready for the actual lamination. And then we're going to proceed to apply some Ease Release 200 to the actual melamine surface. To apply the Ease Release 200, we're going to simply spray a mist of the release, then use a dry brush and brush it around, and then apply one more layer, spraying the entire piece. This is called a spray brush spray technique. The release agent is now allowed 15 minutes to dry before applying any material to it. Now, like I mentioned, we're going to be using carbon fiber for this project to make this a nice and strong piece, yet keep the weight down. Also, it looks really nice and sporty in any kind of car setting. Now we're going to put down some painter's tape around the edges where we're going to cut it. This is going to help us to keep the weave pattern aligned and don't disturb it. It's also going to help us preventing any of the cut edges from fraying. So here we have two of the carbon fiber sheets we cut down. This is going to be the first two layers that we're going to use for the face coat, and then we're going to back it up with glass fibers. Glass fibers are a lot less expensive product, and we need to build up a thickness of 4 millimeters. That's what we're aiming for. So therefore, we're going to use another 4 layers of the glass fibers. Now, the same thing goes for the glass fibers here. We don't want to disturb the weave pattern in the cloth, so while we don't need to handle it just as gently as the fiber cloth, you don't want to bunch it up, tug it, pull it to disturb that weave pattern, because that's where a lot of the strength of the material comes from. Now, we do need some basic tools for this layup. I'm going to use some of these plastic squeegees or spreader tools. When we're going to have some regular chip brushes. And then one extra tool that I like to use on these layups are these rollers. They come in different configurations and are used for different applications. And in the laminating industry, they're widely used to help spread the material and push the air out of the layup that we're doing. Now, because we're working upside down and our face coat is the first layer that we're putting down, it's important to use a tool like this to push the air bubbles out of the front of the face coat. We don't want to do all this work to discover later on that we have huge air bubbles in the face coat that are going to be visible. The product that we're using for this project is the EpoxAmite HT. Now, to keep a couple of things in mind, this product is a by weight only mix ratio, so 100A to 33B. An accurate gram scale is necessary. Your pot life is 60 minutes, depending on the mass concentration, of course. And the full cure time is 24 hours. But more importantly, why we chose to use the EpoxAmite HT is the HT factor. The high temperature deflection that the product offers us is really important. The door panels might be in a hot car somewhere in California, Arizona, Florida, you name it. And the last thing you want to see is the actual panels disforming due to the high temperature of the sun and surrounding. So to avoid that, we ended up going with a high temperature laminating resin to avoid any kind of issues down the road. Now, when it comes to laminating and the quantities of epoxy that you need, the rule of thumb is that you're going to be using the same amount of epoxy resin to the weight of the cloth. So the cloth itself is going to be weighed out. So we have our glass cloth and then our carbon fiber cloth here. Now, you can do some math and figure out exactly how much epoxy you need, or you can always jump onto the Smooth On website and go to our materials calculator page, and there you can scroll down and you're going to see some advanced calculators: volume and surface, volumetric yield, linear coverage, and by weight mix ratio. That's what you want to use. You want to click on that, and that's going to allow you to pick the material that you're using and then put the target weight. And that's going to separate the material and give you exactly how much of A and how much of B you need for this mix. Now, after doing some calculation, I came to the conclusion that I need 700 grams of the part A, and then we're going to add 231 grams of the part B. And again, make sure you use an accurate gram scale for the dispensing of this product. Now we can go ahead and mix this thoroughly. You want to scrape the sides and scrape the bottom of your mixing container. Keep in mind there is no color indicator when you mixed thoroughly, so scrape the sides and scrape the bottom. And then once you're done mixing, we're going to transfer this into a clean second mixing container. And we're going to repeat the same procedure of mixing the epoxy. Now, I do have a little bit of extra material, or more than the weight of the cloth, which is actually a good thing. It's better to have a little bit of extra on hand that you end up wasting anyways in the mixing cup and in the transferring than not having enough when you need it in the project. To eliminate any kind of air bubbles being trapped on top of our insert that we're doing, so that transparency film that we're using, I'm going to brush on a thin layer of the EpoxAmite HT onto the surface. Once that is brushed on, we can put it aside and brush on a layer of the epoxy onto our working surface that you see underneath. Now we can go ahead and dispense some of that material. You can see that I'm staying within the perimeter that we marked earlier. That doesn't mean that the epoxy won't flood out anywhere beyond that, but do note that I'm not pouring the entire batch of epoxy that we mixed earlier. I'm pouring just enough to create a thin film to embed our inlay and the first layer of the carbon fiber. Now the insert we made is carefully placed in place, and then I'm going to add a little bit of the epoxy onto the back side here because we are going to be laying cloth over this, and I want the cloth in that area to not only saturate but actually adhere very well to this insert that we're putting in here. So once the epoxy is rushed on that, we can carefully and slowly inlay our carbon cloth, and you can see here that I lay out the half first and then I unfold it. This helps me to keep the carbon fiber cloth weave pattern wrinkle free while I'm applying the first layer, and this is going to be again the most important layer because this is going to be our face coat of our layup. So it's really important to take precaution right here in this step. Now we're going to use a squeegee tool and we're going to basically push the epoxy through the cloth. This is called impregnating the cloth. Keep in mind that the epoxies are exothermic, and that means that the more mass you have in the mixing container, the faster it's going to set off and start to react, generating heat. So if you don't anticipate using the material fast, make sure you transfer it into a larger container or something where the material is not as mass concentrated. Once that is done and you're satisfied, you know that you covered everything well, we can go ahead and lay down the second carbon fiber cloth that we cut to size here. And then we're going to repeat the same procedure as far as penetrating the epoxy into the cloth, making sure that it's fully saturated. Since the first layer is going to be the face coat of our project, it's really important that we eliminate any kind of air bubbles that might be trapped in that face coat. So this is where those rollers going to become very helpful. We're going to use them to not only spread the epoxy throughout the carbon fiber cloth evenly, but also pop those micro bubbles. So those micro bubbles going to get pushed out with these rollers. So it's really important to understand and use the right tools for the job. Now we can go ahead and put down some more epoxy. This is going to be for the subsequent layers of the glass cloth that's coming. So again, the epoxy is spread around with the squeegee tool, with our spreader tool. And once we have a nice layer of epoxy, we can lay the glass fiber cloth into the epoxy itself. And then again, use the rollers, use the scrapers to fully allow that epoxy to penetrate into the cloth. Now this procedure is repeated until all the glass fiber cloth is used up. I have 4 layers of the glass fiber cloth and 2 layers of the carbon cloth here. It gives us a total of about 3 millimeter thickness, and that's exactly what I was aiming for. And again, at the end you want to make sure that you roll out the epoxy to make sure that it pops any of the bubbles that might be still present in the material, and also to spread the material as evenly as possible throughout the whole layup. This entire layup is now allowed a full cure of 24 hours. Before we demold the layup that we did for our panel here, we're going to follow the instruction in the technical bulletin and actually post-cure the part before trimming it down. So what is post-curing anyways? Post-curing is a process where the finished casting or the layup that you made is exposed to elevated temperature in a specific schedule. That will increase the durability, the strength, and heat deflection of the final piece. Now, what's heat deflection? Heat deflection is basically the temperature that you can expose the material to before it starts to deform. So if your heat deflection is 150 and the temperature that you're exposing your material to is 180 Fahrenheit, that means that the product most likely will soften and deform. In order to remedy that, the material that we're using is a high temperature deflection product. So to reach that high deflection, we do need to post-cure the material. There is two ways to post-cure this product, and we're going to follow the second option, because if we post-cure it above 220 Fahrenheit, it will yellow the epoxy, and we don't want to do that. We want to keep it clear. So after it's been rolled into the oven, we can then turn the oven on and follow the post-curing procedure. Once the post-curing procedure is finished, we're going to allow our layup casting here to cool down to room temperature in the oven without removing it. Now, if you don't have a large shop oven like we do here, that's not the end of the world. You can always build yourself a hot box for projects like this. To find the instructions for how to build a hot box, just follow the link in the description below, and that will take you to a step-by-step procedure on our Smooth On website on how to do so. And now that our part has fully cooled down, we can go ahead and demold it from our working surface. And you can see here how easily that peels away from the working surface. And here we can see our final face of our casting, of our layup, and you can see that it looks absolutely amazing. I was really happy with the way this came out. The results were great. Now I'm going to use that same old stencil to trace out the edges once again with a silver marker this time. This is going to help us see the actual shape, as you can see here, and you can see where that inlay is going to be on the door panel. One quick heads up here, make sure that you're lining up your stencil the right way so that you don't end up with two left or two right door panels. And one more thing, you can see here clearly how important it is to have that extra material over the edges of where you're actually making your part, because you're going to be cutting that away anyways, and you don't want to have any soft or frayed edges on your actual door panel. So always account for a little bit of extra in the process. Now we can go ahead and trim our door panel to size. And as always, whenever you're cutting or grinding or sanding any kind of epoxy, you want to make sure that you're using the correct respirator. And once that is cut, we can focus on some of the detail, cut out the holes for the door handles, drill the holes for the bolts, and then proceed to actually sand some of the edges. I'm simply going to take a piece of sandpaper. This is 220 sandpaper, and I'm going to wrap it in a wood block, nice and straight edge, and I'm going to simply sand the edges, making sure that there's no sharp edges or pieces sticking out that you can potentially cut your fingers on. Now, once this is all sanded, we can give it a quick wipe to clean off any dirt, debris, and release agent still present on our layup. And for that, I'm simply using isopropyl, or you can also use denatured alcohol. And here you can see the end result of our project. These are the finished panels, and they look absolutely amazing. I'm really happy with the way this project came together. They have the heat deflection that I wanted, and also tie in the interior of the vehicle together with the seats. As you can see, the panels are nice and lightweight. They're strong, yet they're flexible, and they will not break easily. Now we're ready to get these installed and see how they look. And here we have it. The time for installation has come. I'm simply going to fit this door panel in its place, and you can see because we used the original stencil from it, this fits perfectly in place. And I'm simply going to use a bunch of plastic rivets that are very common in this application to actually secure the panel in place in the door. And there it is, a couple of more rivets going in, and the project is finished. This looks absolutely stunning, and I'm really happy how this came together, especially with that insert that ties the seats and the door panels together, making the whole project look more complete. Now, if you got inspired by our project and you'd like to give your own projects a go and need some product, you can visit any one of our distributors around the world. So, and there you have it, a step-by-step procedure that I use to create these carbon fiber and EpoxAmite HT door panels that are super lightweight yet super strong. Now, if you have an idea about what we should do next, please let us know down in the comments below. And if you like this video, hit the thumbs up button. Now, to keep up with our latest mold making and casting videos, remember to subscribe.